Our next topic is color of different bodies. Now, there are two types of bodies: transparent bodies and opaque bodies. Now, an opaque body has that color which color of light it can reflect, absorbing all other colors incident on it. So, an opaque body has that color which color of light it reflects, absorbing all other colors of light incident on it. On the other hand, a transparent body has that color which color of light it can refract, absorbing all other colors of light incident on it. Now, so this is how color arises. So you see, color of opaque body arises by reflection, and the color of transparent body arises by refraction. Now, some illustrations can be given here. Say, red flower appears red. Why does it appear red? A red flower has that characteristic that it can reflect only red color of light but absorbs all other colors incident on it. So if a red flower is illuminated by white light, we see it red, for only the red component of white light is reflected from it, and all other components are absorbed. And a green leaf appears green as it reflects only green color of light incident on it, but it absorbs all colors of light incident on it. Now suppose a red flower and a green leaf, they are placed on a table in a room, and they are illuminated successively, at first by red light, then by green light, then by blue light, and then white light. Red flower with green leaf, first illuminated by red light, then green light, then blue light, and last of all white light. How do they appear in each case and why? In red light, the flower definitely appears red, as it reflects the red light, but the leaf appears black, as the leaf cannot reflect the red light. Only red light is there, so it absorbs the red light, and so it appears black. On the other hand, if it is illuminated by green light, the flower appears black. As the light is green, the flower absorbs the green light, and no light is reflected from the flower, and so it appears black. But the leaf appears green, as the green light is reflected easily from it. And when illuminated by blue light, both flower and leaf appear black, for both of them absorb the blue light, and no light is reflected either from leaf or from the flower. In white light, the flower appears red and the leaf appears green. The flower reflects the red component of white light, absorbing other components, and the leaf reflects the green component of white light, absorbing other components. That's why the flower appears red and the leaf appears green. Now, white and black, these are not definite colors. Sometimes it is called white and black are no definite colors. Why? Actually, we see an object white when all colors of light incident on it are reflected, and no light is absorbed in it. It appears white when all colors of light are reflected and no light is absorbed. On the other hand, an object appears black when all colors of light are absorbed in it and no light is reflected from there. And that is why white and black are called no definite colors. The presence of all colors of light is white, absence of all colors of light is black. And you can tell we write with white chalk on blackboard. The white chalk on blackboard, the background is black, so no light is reflected from the board, and the all colors of light are getting reflected from the white writings, and that's why the writings become prominent on the blackboard. But the reverse thing happens in a book. So black printings on white page. Black printings on white page we can read. Actually, the printings do not reflect any light from them, but the white page of the book reflects all colors of light incident only. And that's why the black printings, although they do not reflect in light, they become very much distinct on the white background, and so we can easily read them. So we can read the black writings as we do not see them on white page, and that's why you can read them. Now, refraction, on refraction I can tell that, say, a red flower in sunlight. Suppose there is a red flower in sunlight, and you are provided with a red glass and a blue glass, and you are looking through red glass and blue glass. How does the flower appear in each case, and why? Actually, while looking through red glass, the flower appears red. Why? Actually, the flower reflects the red component of white light, sunlight. Sunlight is white light, so red component of white light is reflected from the flower, and the red light reflected from the flower is easily transmitted or refracted through the red glass to reach your eye, and so you can see the flower red. You can see the flower red. But if you look through blue glass, the flower appears black. Why? Actually, the red light reflected from the flower is totally absorbed in the blue glass, and no light from the flower is getting refracted to reach your eye, and that's why the flower appears black. So through red glass, the flower appears red, but through blue glass or any other color glass, the flower appears black. Now, when does a transparent body appear colorless? When does a transparent body appear colorless? Actually, a transparent body appear colorless when all colors of light are refracted in proportional amounts, in their respective proportions, in which proportions they are present in white light. So, if all colors of visible light are refracted in their respective proportion through a transparent body, then the transparent body appears colorless. A colorless substance, transparent body, say glass, water. So all colors of visible light are getting refracted in their proper proportions, and that's why they appear colorless. So next topic is electromagnetic wave theory of light. Electromagnetic wave theory of light, it was given by Maxwell in 1865. In the year 1865, he enunciated he told about the electromagnetic theory. He developed electromagnetic theory, wave theory of light. According to electromagnetic wave theory of light, light wave is an electromagnetic wave, but it is transverse in nature. Electromagnetic wave means is actually the movement of electric field and magnetic field together. The two field, electric field and magnetic field, they are perpendicular to each other, and the two fields are moving simultaneously in a direction perpendicular to both the field, and that is electromagnetic wave. Electromagnetic wave, light is electromagnetic wave, although it is transverse in nature. It is transverse in nature. Now, wavelength and frequency are, according to electromagnetic theory, the wavelength of red light is the greatest, and that of violet is least. Wavelength and frequency is the reverse one. The frequency of violet light is the greatest, and this is the least for red. Now, according to electromagnetic theory, a relation between refractive index and velocity of light can be obtained. The relation between refractive index and velocity of light, according to electrometric theory, the refractive index of a medium. I told you earlier that refractive index, by refractive index, only refractive index, we mean absolute refractive index or the refractive index of a medium with respect to air. Now, refractive is a medium can be related with the velocity of light. Suppose I am telling the refractive index of medium, say with respect to air, then we can write it, the refractive index is equal to velocity of light in air divided velocity of light in that medium. If you tell air mu glass, so air mu glass is equal to, you can write according to electrometric wave theory, air mu glass is equal to the ratio of velocity of light in air divided by velocity of light in glass. Air mu water, the ratio of the velocity of light in air divided by velocity of light in water. So this is how we can tell relation between refractive index and velocity of light. If we tell about absolute refractive index, that is with respect to vacuum, then you can write absolute refractive medium is equal to ratio of the velocity of light in vacuum divided by the velocity to the velocity of light in that medium. Suppose I am telling absolute refractive index of glass is equal to velocity of light in vacuum divided by velocity of light in glass. Absolute refractive of glass you tell, so velocity of light in vacuum divided by velocity of light in glass. Absolute refractive index of water, velocity of light in vacuum by the velocity of light in water. So this is how we can relate refractive index with velocity. Now one thing, absolute refractive index of medium, I told you earlier, the absolute refractive index of medium is always more than 1. Absolute refractive index of medium is always more than 1. It is also clear from here, from this wave theory, that absolute refractive index is equal to, I told you the absolute refractive index is equal to, of a medium is equal to velocity of light in vacuum divided by velocity of light in that medium. Now we know the velocity of light is the greatest in vacuum, as the vacuum is the rarest among all optical media, and so the velocity of light in vacuum is the greatest. So obviously, so the numerator of this fraction is always greater than the denominator. Whenever you tell about the absolute refractive index of a medium, then the numerator is always greater than the denominator, and so the ratio is always more than 1. So we can also tell from this relation that absolute refractive index of a medium is always greater than 1. Our next topic is applications and harmful effects of ultraviolet rays, X-rays and gamma rays. Applications and harmful effects, these are given in your book. You can see your book. I am telling some applications and harmful effects. So of ultraviolet rays, applications you can tell, it is used as for initiating different chemical reactions. To initiate different chemical reactions, ultraviolet radiation are used. Ultraviolet radiation is also used in aquaguard, ultraviolet for sterilizing water. So ultraviolet radiation is used. Ultraviolet radiation is also used in ultraviolet torch, UV torch. UV torch, ultraviolet radiations are used. And harmful effects of ultraviolet radiations, you can tell that it can destroy microscopic organic cells. It destroys organic cells. Ultraviolet radiation on incident on skin can cause skin cancer, that is melanoma. Skin cancer can occur with the help of ultraviolet radiations. With the help of this radiation, the plants' lives are also affected. Next comes X-rays. Applications of X-rays. I am telling it is given in your book. I am telling 2 or 3 applications. In medical science, X-rays are used in radiography for diagnosis and also in radiotherapy for treatment of cancer, tumor, etc. In medical science, it is used in radiography as well as in radiotherapy. And in X-rays are also in commercially for detecting hidden flaws on different iron beams, wooden beams, etc. If there are some cracks within the beams, it can be detected with the help of X-rays. In customs department, the X-rays are used for to prevent smuggling of contraband commodities. In the harmful effects of X-rays, X-rays destroy organic cells. Hard X-rays destroy to large organic cells, highly human cells, and if X-ray photographs is taken for the same part of the body repeatedly, then it can cause cancer on the skin, cancer on the skin. Now, next one is gamma rays. In radiotherapy, gamma rays are used. Use of gamma rays, you can tell in medical science, radiotherapy with the help of for the treatment of cancer, tumor, etc. In case of radiotherapy, gamma rays are used, and in different nuclear reactions and artificial transmutation of elements, gamma rays are widely used. Artificial transmutation of elements and in different nuclear reactions, gamma rays are used. And harmful effects of gamma rays is high penetrating power, so it destroys human cells to a large extent, living cells to a large extent. And if someone comes in contact with gamma rays for a long time, genetic effect can also occur. So these are the harmful effects of gamma rays. Our last topic of light is scattering. The scattering of light. What is scattering of light? When a light ray traveling through a medium is incident on fine dust or smoke particle or gas molecule, a part of the ray is absorbed in it and then is radiated with the same wavelength in different direction. This is called scattering. I am telling again, when a light ray traveling through a medium is incident on fine dust or smoke particle or gas molecule in a medium, a part of the ray is absorbed in it and then is radiated from that particle with the same wavelength but in different directions. This is called scattering. And scientist Rayleigh gave one formula for scattering. The intensity of scattering of a light is inversely proportional to the fourth power of the wavelength of the light. If the intensity of the scattering is I and wavelength is lambda, then we can tell the I is proportional to 1 by lambda to the power 4. It is inversely proportional to the fourth power of the wavelength. So it is obvious the greater the wavelength, less is the scattering. So among all visible colors of light, red light has the largest wavelength, so it is scattered least, and the violet has the smallest wavelength, so it is scattered most. Now, regarding scattering, some illustrations we can tell regarding scattering. The first comes blueness of the sky. First comes the blueness of the sky. Why does sky look blue during daytime? Actually, this happens due to scattering of sunlight by the dust particles, water molecules, gas molecules present in the atmospheric air. Actually, during daytime, the sunlight are getting scattered by those. Now, as the sunlight is scattered by those particles, that is dust particles, air molecules, water vapor, etc., suspended in air. Now, the I told you that the violet light and is the smallest wavelength, but blue is also, after that blue, it comes blue. Now blue, the scattering of blue light and violet light are maximum. And so being scattered, blue light or light to the blue region, that is violet and blue region, comes toward the earth's surface. All colors of light being scattered less do not come toward the earth's surface. They go upwards. So by scattering, the light rays in the blue and violet region come toward the earth's surface. But our eye is more sensitive to blue light, than the violet light, and that's why the sky appears blue during daytime. And that's why we see the sky blue. Similarly, during sunrise and sunset, the eastern and western sky respectively appear red. This also happens due to scattering. And in this case, the red light being scattered least come toward the earth's surface. Actually, sun rays are here obliquely incident on the dust particles, air molecules, or water vapor. And so red light being scattered least come toward the earth's surface. The other lights go upwards. And that's why during that time, during sunrise or sunset, the red light being scattered come to the earth's surface and we see the sky red. Another example we can tell, application of scattering, the traffic red signal. The traffic signal is made red, and actually the cause is it happens due to scattering. We told you that the red light is scattered least. As the wavelength of the red light is the greatest, so it is scattered least by the air molecules, dust particles, or smoke particles present in the air. And so, if the signal light is made red, the light emitted from the signal, after being scattered by the dust particles or air molecules or water, etc., present in the air, water vapor, etc., present in the air, are deviated least from its path. And so, as the deviation of the red light is least, so it can be viewed from a large distance. And that's why the signal light is made red, so that the signal light can be viewed from large distance. And that is why we make the signal light red, as it can be seen clearly from a large distance. So this is how we finished light. The syllabus for revision test up to this, and you just prepare. And if we get class after vacation, if some time permits, then we can discuss more about these things. Now read all the answers, read the book properly, and try to draw the diagrams from yourself. And in drawing the diagrams from light, a very important thing that you must give the arrow signs. Don't forget to give arrow signs while drawing the diagrams. So thank you, and I finished the syllabus of revision test.